Welcome back. In this video, we will discuss maintenance quality assurance. Here we will discuss maintenance software quality assurance tools. In fact, a variety of software quality assurance tools are used throughout the operational period of the software. Uh, the specific nature of each component of software maintenance, for example, the corrective maintenance, adaptive or functionality improvement maintenance, demands that different sets of quality assurance tools be used for each. Moreover, the operational period of the software typically makes intensive use of infrastructure SQ tools and managerial control tools more probable. Therefore, it is important to discuss the tools for different types of maintenance activities and to ensure managerial control of software. So, in the upcoming slides, we will discuss the following maintenance quality assurance tools, and these include SQ tools for corrective maintenance, SQ tools for functionality improvement maintenance, SQ tools for software, SQ infrastructure tools for software maintenance, and SQ tools for managerial control of software maintenance. So, SQ tools for corrective maintenance. Corrective maintenance activities include primarily the user support services and software correction services. For example, these include bug repairs. User support services deal with cases of software code and documentation failures, like incomplete or vague documentation. They may also involve instruction of users who have insufficient knowledge of the software or fail to use the available documentations. Then software correction sources, like this includes bug repairs and documentation corrections. As the two types of services are fundamentally different, therefore different sets of quality assurance tools are used irrespective of the their shared focuses on the quality of services. Even so, in many cases, the same team performs both types of corrective maintenance. It is important to mention that most bug repair tasks require the use of mini lifecycle SQA tools, mainly called mini testing. Mini testing procedures are required to handle repair patch tasks. That is, these are small scale tasks characterized by a small number of coding line changes to complete the corrections rapidly. In order to assure mini testing quality, there are certain guidelines that should be adhered to. Uh, these include the first one is testing is to be performed by a qualified tester, not by the programmer who carried out the repair. Then a testing procedure document in most cases 2 to 3 pages long should be prepared. This document should contain description of the anticipated effects of the repair, the scope of the corrections, and a list of cases to be activated. A retesting procedure document similar to the testing procedure document should also be prepared to handle the testing of repairs of errors detected in the previous tests. Then another guideline is that a test report fully documenting the errors detected at each stage of testing and retesting should be completed. The next guideline is that the testing documentation uh, to be reviewed or is to be reviewed for scope of corrections and adequacy of tests. That is, the testing team lead in fact needs to review the testing documentation for the scope of corrections, the adequacy of the test cases, and the testing results. Then the last guideline is that avoid mini testing for simple repairs, like for repairs that are considered simple and trivial, especially for those performed at the customer site. Mini testing should be avoided. Then SQ tools for functionality improvement maintenance. Due to the similarity of functionality improvement maintenance tasks to software development project tasks, project lifecycle quality tools such as reviews and testing are regularly applied for functionality improvement maintenance as well. These same tools are also regularly implemented for large-scale adaptive maintenance tasks, where again the task characteristics resemble to those for the functionality improvement tasks. Okay, here we discuss SQ infrastructure tools for software maintenance. In fact, specialized SQ infrastructure tools are needed for software maintenance processes. So here we will discuss some of those tools. And the first one is maintenance procedures and work instructions. In fact, this quality tool refers to work procedures or instructions for remote and on-site handling of requests for service in case of software failures. Then the next one is supporting quality devices. This quality tool actually includes checklists to locate the causes for a failure. Similarly, the templates for reporting how software failures were solved, including the findings of the correction processes, and the checklist for preparing a mini testing procedure document. Then training and certification of maintenance teams. In fact, this quality tool includes infrastructure tools, for example, training and certification of the maintenance personnel. Uh, then preventive and corrective actions. This may include screening the collected information regarding the errors or failures and their repair activities, then, reviewing and analyzing findings, and devising recommendations for improvements of relevant development and maintenance processes. Then configuration management. Since the maintenance teams might be involved in serving the particular software systems for like several years, during which new versions are added, old versions are replaced, and many new installations and changes in softwares are performed. Therefore, devising an appropriate configuration management strategy along with the selection of suitable configuration management tools is important. Then the last infrastructure tool for quality is documentation and quality record control. The specialized requirements for documentation and quality records are most closely related to software correction and user support activities. The next tool we discuss is software quality assurance tool for managerial control of software maintenance activities. Using the specialized managerial control SQA tools for corrective or functionality improvement or adaptive maintenance uh, help in improving the control of maintenance activities by creating early alarms that signal reduced quality of service and increasing rates of like service failures. So here we discuss three types of managerial control issues, particularly related to the software correction and user support services. These issues include performance controls for corrective maintenance services, quality metrics for corrective maintenance services, and cost of software maintenance quality. So first we discuss performance control for corrective maintenance services. Managerial performance controls for corrective maintenance services differ when applied to software correction, for example, failure services, failure repair services, and to user support services. The managerial control tools, besides periodic performance information and alarms for management attention, aim at software correction and providing user support through increased resource utilization. Then the second managerial control issue is quality metrics for software maintenance. Just like we have quality metrics related to software development activities, there are also quality metrics for software maintenance. So software maintenance quality metrics are used mainly to identify the trends in maintenance efficiency, effectiveness, and customer satisfaction. Then the third managerial control issue is cost of maintenance quality. The quality cost of corrective maintenance are classified into 6 classes. Uh, these include cost of prevention, that is cost of error prevention, and it includes cost of instruction and training of maintenance teams, cost of preventive and corrective actions. Then the cost of appraisal, that is cost of error detection, and it includes like costs of reviews of maintenance services carried out by quality assurance teams or like external teams, and the cost for customer satisfaction surveys, etc. Then cost of managerial preparation and control, that is it includes costs of preparation of maintenance plans, maintenance team recruitments, and like follow-up of maintenance team's performance, etc. And then the next is cost of internal failures, and it includes cost of software failure corrections that are initiated by the maintenance teams. Then the next cost is cost of external failures, that is cost of software failure corrections initiated after receiving the customer complaints. Then the last cost here is cost of managerial failure, which includes the costs that are like caused by managerial actions or like inactions, that is costs of damages resulting from shortage of maintenance staff or inadequate maintenance task organization or inappropriate managerial decisions. So here we see that the 3 types of managerial control issues, that is the performance control for corrective maintenance services, quality metrics for corrective maintenance, and cost of software maintenance quality, should be properly taken care of to improve the quality of maintenance services. So that's all about our discussion on quality assurance activities in software maintenance. The materials in this video are based on our course book titled Software Quality Assurance from Theory to Implementation by Daniel Gallen. For more details, you can consult the course book. Thank you.